Anyways, this is lesson 5.3. This is Mrs. Blaufuss here, and it's about adding and subtracting and multiplying polynomials. So in the last lesson, we looked at what a polynomial function is, and we, looked at their degree and their leading coefficient and kind of what their graph looked like. But here is a lesson on how we can combine these polynomials. So if we have multiple, we can simplify and combine our like terms. So the first example is about adding polynomials vertically in the first one, and then the second one is about adding them horizontally. Now remember, you can only add like terms. So if you have an x, you cannot add that to an x cubed, but you can add it to another x. So let's look at this first one. And the important part about adding polynomials, either whether you're doing it vertically or horizontally, is setting it up in standard form. So anytime you're adding polynomials, set it up into standard form so that you have your polynomials organized. So that means putting your leading coefficient as your first term that correlates with the leading exponent. So if you look at it, the first example, both of these are in standard form. Now, if you don't have, if you're missing a term, it helps to write in the 0 times x, because x cubed minus 5x squared plus 3 is the same thing as x cubed minus 5x squared plus 0x plus 3. So always write in those missing terms, just so that when you're setting them up to add or subtract or multiply, that you don't accidentally add terms that are not like terms. So adding these polynomials vertically, once you have them in standard form, you're just adding the like terms together. So 3x cubed plus 1x cubed is 4x cubed. And then a negative 2x squared minus 5x squared is a negative 7x squared. And then a 4x plus a 0x is a positive 4x. And a negative 6 plus 3 is a negative 3. So careful with your signs. Make sure that you carry the sign in front of the coefficient with that term so that you don't make sign errors. Okay, now the next one, adding them vertically. Again, you want to pair up your like terms. So I would rewrite this expression so that all of my polynomials have the same number of terms. So I would rewrite this as 2y cubed plus 7y squared minus 6y plus 0 plus 0y cubed, because in my first polynomial I have a y cubed, so I want to have a y cubed in my second polynomial. So that's 0y cubed minus 4y squared plus 3y minus 9. So when you're adding polynomials, I'm adding this whole group here. I'm adding all of this. So all of these are, it's like a plus 0y cubed plus a negative 4y squared plus a positive 3y plus the negative 9. So when you combine your polynomials, make sure that you pay attention to your sign. So when it's addition, the sign inside the parentheses is what you're focusing on, but when it's subtraction, remember that you have to distribute. So let's do this addition one first. So 2y cubed plus 0y cubed is 2y cubed. So I took care of those ones. Now my 7y squared minus 4y squared is 3y squared. So I took care of those ones. And then negative 6 plus 3 is negative 3y. Took care of these ones. And then lastly, 0 plus a negative 9 is minus 9. So again, make sure that you have these written in standard form, and then you add your like terms. Now, when you're subtracting polynomials, this is true vertically or horizontally, like we said in the previous slide, but you're subtracting 6x cubed, subtracting positive 3x cubed, subtracting a negative 7x, and subtracting a 5. Okay, so make sure that you include that subtraction sign for each of the terms. So 7 minus 5. And again, set it up into standard form. And actually, I'm going to have to rewrite these because the second one actually has an error. Or not an error, but it's not in standard form. So rewrite these so that they're both in standard form. So we've got 7x cubed minus 6x squared minus 3x plus 7. So notice that the second polynomial, you can combine those terms. So it's 6 plus 3 is 9. So order of operations says do your parentheses first. So we have to do parentheses first, and we end up with, we're subtracting 9x cubed, and then 0x squared, and subtracting from a negative 7x, and a positive 5. So if it's not already in standard form, do that first, just to help yourself get organized. So now it's 7x cubed minus a 9x squared. A 9x cubed is negative 2x cubed. Negative 6 minus 0 is still negative 6x squared. Negative 3 minus a negative 7 is a negative 3 plus 7, which is 4x. And a positive 7 minus positive 5 is 7 minus 5, which is a positive 2. Right, and then in the next example, when you're subtracting polynomials horizontally, same thing, you want to put them in standard form, which in this case it looks like they are, but don't forget to distribute this negative sign to each term. So if you want to rewrite it, you can do that, or you can just make sure that when you are subtracting polynomials, you change the sign inside your group. So that's 8x squared minus positive 12x squared, which is negative 4x squared. Okay, I took care of these. Now I have a negative 5 minus a negative 9. So that's a negative 5 plus 9, which is positive 4x. All right, now I took care of those terms. Now I've got 11 minus a negative 3, which is 11 plus 3, which is plus 14. And that's my answer. All right, so pause while you work. There are 2 more. Find the sum or difference. Don't forget, if you have a negative, you're subtracting a whole polynomial group. Make sure you distribute that negative sign to each term. So pause while you work, and then you can unpause for the solution. All right, in this first example, you have to rewrite this into standard form. And again, I would rewrite it so each polynomial has the same degree, even though your first one will have a leading coefficient of 0. So when you do this, you get 0t cubed minus 5t squared plus 8t plus 6 minus the whole polynomial, the whole group, 2t cubed minus 3t squared plus 0t plus 7. And again, I include those zeros just when I'm showing my work, just so that I can organize my like terms a little more easily. So your final answer should be negative 2t cubed minus 2t squared plus 8t minus 1. So don't forget to distribute that negative sign to each term. In the second example, it's already in standard form for you with the same degree. Each polynomial has the same degree. So in this case, you're just adding and you're combining like terms to get 12p squared minus 13p minus 2. Our next step is to multiply polynomials, and we can do this vertically or horizontally. So again, put it in standard form so you have the same, so that your coefficients line up together. So in the first one, multiplying vertically, this is just like you would multiply double-digit numbers together. So this is not an x, this is actually a multiplication sign. All right, so when you multiply, you're going to multiply this 2 by each of these terms, by 4, by negative x, and by 3x squared. So 2 times 4 is 8, 2 times negative x is negative 2x, and 2 times 3x squared is 6x squared. And then you're going to add all of the x, all the products of x. So just like when you're multiplying double-digit numbers, you're going to put a 0 in this first place value, because now you're multiplying the second to last term, rather. So you're going to multiply x times 4, x times negative x, and x times 3x squared. So x times 4 is a positive 4x. X times negative x is the negative x squared. And x times 3x squared is 3x cubed. Now that you have done the multiplication part, you need to still add these polynomials. And if you've multiplied like this, multiplied vertically, then you're going to be adding vertically. So 8 plus 0 is 8. Negative 2x plus 4x is positive 2x. Don't forget to carry forward your signs too. And then 6x squared minus x squared is positive 5x squared. And 0x cubed plus 3x cubed is 3x cubed. So this is your final answer. When you're multiplying horizontally, you can use the FOIL method, even though you have a larger polynomial, but you're going to take this first term, x, and multiply it by each term in the second polynomial. So x times x squared, x times 2x, x times negative 5. So x times x squared is x cubed. X times 2x is 2x squared. And x times negative 5 is negative 5x. And then you're going to do the same thing with your negative 3. Multiplied by each term in the second polynomial. So negative 3 times x squared is negative 3x squared. Negative 3 times 2x is negative 6x. And negative 3 times negative 5 is positive 15. And now you need to combine your like terms. So we've got 1x cubed term. And then 2x squared minus 3x squared is negative x squared. And then a negative 5x minus 6x is negative 11x plus 15. So always make sure that your final answer has all of the like terms combined. Otherwise, it's not in simplest form, and you will, on quizzes and tests, and even when you check your homework, your answer won't be simplified. So always combine your like terms. Now, as your binomials get more, as you get more of them, and as you start to factor and simplify your polynomials, you may get more than one or more than two binomials. And in that case, just remember that multiplication is commutative. So it doesn't matter which set of binomials you multiply first, but you are going to have to multiply one set and then that product times the next set. And then if you have 4, that product times the fourth set of binomials. So we're going to do this one together, multiplying 3 binomials. So I generally work from left to right, but again, multiplication is commutative, so it does not matter which group you multiply first. So to start, I'm going to multiply these two binomials together. You could also, if you wanted to, start with these two binomials. It doesn't matter, again, because multiplication is commutative, but I'm going to start with the first group, or the first two, rather. All right, so I'm going to multiply x minus 3 times x plus 7, and to do this, we're just using FOIL. So I get x squared plus 7x minus 3x minus 21. And it's going to be that whole group times my last binomial set. All right, so now I'm going to simplify what's inside my parentheses. So this becomes x squared plus 4x minus 21 times x plus 1. Now this is just like what you had in the last example, where you have a trinomial and you're multiplying it by a binomial. So I'm going to multiply x by each term, or sorry, x squared by each term. So x squared times x is x cubed. X squared times 1 is x squared. And then I'm going to do the same thing with my next term. 4x squared times x and 4x times x and 4x times positive 1. So that gives me 4x squared plus 4x. And then I'm going to do the same thing with my last term, negative 21. And remember, it's that negative 21 is the term. So I've got negative 21x minus 21. And that's my answer, but it's not simplified. So now I have to simplify, add my like terms together. So I've got x cubed, I have one of those. Then I've got a couple x squareds. So x squared plus 4x squared is 5x squared. And then I've got a couple of just x values. So 4 minus 21, that's negative 17x. And then I have a single constant term. And that is your final answer. All like terms are combined. We have a few special product patterns, and you'll see these, and these will come up especially when you're factoring. These are going to be super helpful. But a plus b, the quantity a plus b times the quantity b minus a equals a squared minus b squared. So if you apply that rule to this first example, where your x, and actually that's sum and difference, it should actually be a minus b. It should be the quantity a minus b. So a plus b times a minus b. That actually, using those variables is how that rule should be set up. Equals a squared minus b squared. Okay, so in your first example, this is your a, so that's x squared, and this is your b, minus 2 squared, which is 4. The square of a binomial, a plus b quantity squared, equals a squared plus 2ab plus b squared. So you should recognize that from last chapter when we did perfect squares. So y plus 4 squared is going to be your a squared, which is y squared, plus 2 times a times b, so 2 times y times 4, that's 8y, plus your b squared, which is 4 squared. And then the difference of a square, so a minus b squared is a squared minus 2ab plus b squared. So in this case, this whole thing is your a, and this whole thing, oops, a negative. This whole thing is your A. And this is your B. Okay, so your A is 3p squared, and you're going to square that. So if you remember your rules of exponents, that's 9p to the fourth. Minus 2 times A, so 2 times 3p squared, times B, which gives you negative 12p squared. And then you're adding b squared, which in this case is 2. So you're adding. Right, and then these next two rules are new rules. So these are cubes of a binomial. So a plus b cubed. You look at the square of a binomial, you're dealing with 2. But here, in a cubic binomial, you're dealing with 3, which cube is 3. A cube has 3 congruent sides. So a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. So x plus 1, where this is a and this is b. You have x cubed plus 3 times x times, or 3 times x squared, which is 3x squared times 1, which is 3x squared, plus 3 times x times 1 squared, which is just 3x, and then 1 cubed, which is just 1. And then in the last one, your difference, it's the same general rule, except these signs are negative. Because if you think of how cubing a negative number works, if your b is, this is negative 2, and you're going to square it, it still is positive 4, but if you're going to cube it, it becomes negative 8. So that's why those two terms are going to be negative. So in this case, r is your a, and 3 is your b. Okay, so the rule says, and we'll do this with the next alternate colors. So the rule says a cubed, so that's r cubed, minus 3 times r squared times b. So 3 times r squared, which is 9r squared, plus 3 times r, 3 times r times 3 squared. So 3 times 9 times r, which is 27r. And then the last part of your rule is minus b cubed, which is minus 3 cubed. 3 cubed is 27. Okay, so those are examples of how to apply those rules. And again, you're going to practice with these, you're going to use them a lot, and you're going to remember these patterns or kind of where to start with these patterns. So the more you use it, the more familiar you're going to get with it. So we're going to use the special product patterns in order to multiply out these binomials, either the difference of binomials, the square of binomials, or the cube of binomials. So take a minute and try to apply these on your own. And you can unpause for the solution. So in the first one, it's 7m squared, that's your a, minus your b squared, so 49m squared minus 9. Right, in the second one, your 4t cubed, that's your a, your 6 is your b, so you got 4t cubed squared plus 2 4t cubed 6 plus 6 squared. So that gives you an answer of 16t to the 6 plus 48t cubed plus 36. So don't forget about your properties of exponents. You're taking a cubed power squared. That's 3 times 2. That's why it's t to the 6th and not t to the 5th power, because it's a power of a power. and you have to take each term to that second power. And then the last one, your xy, that's your a term, and your 4 is your b term. So please double check your answer along with what you have. Your final answer should be x cubed, y cubed, minus 12x squared y squared, plus 48xy, minus 64. Now, if you were to multiply these all out, if you were just to write that as 3 trinomials, you would get the same answer. It just, without these patterns, you would have to multiply using the FOIL method for each binomial. So it just might take a little longer. These are shortcut patterns, but by all means, you can definitely do it without, but this is just a good starting point. All right, so please try the next 4 on your own. You can use the special pattern properties, and you can unpause the video after you have your solutions. And some of these have special patterns, and some of them do not. So use your special patterns when you can, but not all of them will apply. Right, so if you look at this first example number 3, where you're finding the product, you're going to use the FOIL method. So you're going to multiply x minus 2 by each of these terms, and then add like terms. So here's your answer for number 3. Please check your work. For the next one, you're multiplying 3 binomials. So again, it doesn't matter which ones you multiply first, but the product of 2 binomials times the third binomial. So the product of the two binomials, I multiply the first 2 together to get x squared minus 3x minus 18. Again, don't forget to add like terms. So the product of the first 2 times the third one. And then again, make sure that you simplify by adding all like terms. Then the third one, example number 5, 6 cubed minus 3r squared. That's the difference of a squared binomial. So difference of perfect squares. So you've got your a squared minus 2ab plus b squared. And then the last one is the sum of a cube binomial. So you can use the rule at the top of this note sheet for that example. So please jot down any questions you have, and we can go over these next time I see you in class. Thank you.